Hey everyone, welcome to The Explainer. I am so pumped to be with you today because we are tackling a seriously fascinating shift in the software engineering world. We're looking at how AI prototyping is evolving, specifically when our production code moves towards strict reverse vibe coding or RVC frameworks. Now, if you've been following the AI coding space, you know there's this massive debate going on, right? Like, do we let AI write our core business logic or do we pull it back? Well, today we're exploring exactly what happens when we do pull it back and how that actually unlocks this completely new structured superpower for our teams.
So here's the massive question we really have to ask ourselves. We know that RVC workflows are designed to completely kill off unstructured vibe coding for production code, right? Instead, RVC relies on these strict domain-specific language, or DSL-driven RVP flows, and that's to ensure absolute code provenance and prevent any weird AI drift. It's rigid, it's highly structured. So, if we're locking down our production environments this tightly, what happens to the rapid, free-flowing nature of vibe coding? Is the vibe just completely dead? Have we literally just gone back to the dark ages of typing out everything by hand?
Actually, the answer is a resounding no. It just moved to the laboratory. Seriously, vibe coding isn't dead at all. It's just been purposefully repurposed. So instead of being this risky tool that we use to blindly write the core business logic running our apps, it's become this exclusive, super powerful tool strictly for prototyping, running experiments, and communicating. Basically, we've taken the chaos out of the factory floor and moved it safely into the R&D lab, complete with safety goggles.
Okay, let's dive into this. Section 1, the RVC prototyping pivot. We're going to look at how pushing uncertainty upstream completely changes the game.
Because we want to keep all that AI ambiguity completely away from our core business logic, I want you to really focus on this idea from the source material. The experiments are deliberately disposable. They exist to inform future design decisions, not to be refined or integrated. Let me ground this for a second, because this is an absolute non-negotiable rule in this framework. When we say disposable, we mean it. Absolutely none of this experimental AI code goes into production. Zero. You don't clean it up, you don't refactor it, you definitely don't integrate it, you learn from it, and then you literally throw the code in the trash. It exists purely to give you the knowledge you need to hand code the real thing properly.
Moving on to Section 2, POs and the living spec. This pivot completely changes the landscape for non-developers, specifically product owners, who can now actually use vibe coding themselves.
And that brings us to this honestly brilliant concept, the living spec. You can think of this as executable intent. Instead of just writing down some ambiguous ticket and, hoping for the best, a product owner uses rapid AI vibe coding to build a runnable, completely disposable prototype. It physically demonstrates exactly what the PO thinks they asked for. This living spec is then shared with stakeholders to make sure everyone is on the exact same page, and then it's handed off to the developer as a crystal clear communication tool. It's amazing for ensuring perfect alignment before a single line of hand-coded production logic is ever written. And remember, just like all experiments here, the living spec code gets tossed straight in the bin once the intent is fully understood.
So, we've drawn a really sharp line here. On one side, a PO's prototyping, that living spec we just talked about, is entirely focused on communication, behavior, and stakeholder alignment. It's all about the what. But on the other side, developer prototyping is an entirely different beast. For developers, this isn't about user features. It's about building what we call an inspiration wall, focused on pure technical experimentation. It's about the how. Let's look a bit closer at what developers are actually doing on their side of the fence.
All right, Section 3, developers and the inspiration wall. Let's cross over to the developer's side of the equation.
When a developer is faced with, say, a complex new architecture or some tricky integration, they don't just start writing production code anymore. Nope. They use the AI as a sparring partner to rapidly fill an inspiration wall with disposable micro-experiments. So the crucial thing here is following 4 strict steps. Step 1. You build your disposable experiment using AI to test frameworks and explore edge cases. Step 2. You run it, test the library, and validate those architectural assumptions. Step 3, and honestly this is the hardest one for a lot of developers to accept, you discard the AI code. Just delete the branch. Poof, gone. Then Step 4. Armed with the exact knowledge of how the architecture should work, you hand-code the production logic yourself. By hand-coding, you ensure deliberate, strict adherence to DRY, don't repeat yourself principles, which we all know AI notoriously struggles with. You're getting the raw speed of AI learning combined with the rock-solid maintainability of human engineering.
Now for Section 4, 2 paths to inspiration. How do developers actually generate this experimental code? Well, they now have 2 distinct paths.
Those 2 options are Path A
traditional vibe coding, and path B, seed coding. Now, we are all pretty familiar with path A, right? Traditional vibe coding is that chaotic, prompt-heavy, super iterative chat process where you're basically just throwing ideas at the large language model and wrestling it toward a working prototype. It's fantastic for broad strokes. But path B, seed coding, well, that's a newly introduced alternative. It offers a completely different flavor of experimentation for developers who might need something just a bit more refined.
Which brings us to Section 5, the seed coding alternative. Let's look at this structured approach for generating experimental developer code.
To put it simply, if vibe coding is like throwing paint at a canvas just to see what sticks, seed coding is a lot more like using a stencil to generate a very specific pattern of inspiration. When we compare their styles, vibe coding is incredibly unstructured and free-flowing, while seed coding is highly structured and deliberate. In terms of pace, vibe coding is all about rapid, kind of chaotic ideation. Seed coding, on the other hand, is a measured generation process. You put way more thought into the initial parameters up front to get a much more specific output. Because of that, vibe coding is best for broad conceptual exploration, like a PO trying to figure out a messy UI flow, while seed coding really shines for focused technical prototyping. That's where a developer needs to test a very specific architectural interaction on their inspiration wall. Basically, it gives developers a much tighter grip on the output of their disposable experiments.
And what's truly powerful here is that seed coding is actually a stand-alone prototyping technique. While it was totally born to fit perfectly onto the RVC inspiration wall, giving developers that structured disposable code we talked about, it adds massive value even outside of the strict reverse vibe coding framework. Seriously, even if your team is just using traditional agile or standard AI-assisted workflows, integrating the structured approach of seed coding for your prototypes can vastly improve the quality of your experiments. And the best part? It doesn't lock you into the entire RVC methodology. It is just a super versatile tool to add to your engineering toolkit.
Well, that brings us to the end of our explainer today, and I really want to leave you with this final provocative thought. Take a hard look at your current workflows. How will you separate your disposable inspiration from your production reality? Are you letting unstructured AI experiments kind of bleed into your maintainable code base? Or are you ready to build an inspiration wall, embrace a living spec, and keep your production reality clean, hand-coded, and entirely under your control? It's a huge paradigm shift, for sure, but mastering this boundary might just be the absolute most important software engineering skill of the next decade. Thank you so much for joining me to explore this topic. Keep learning, keep experimenting, and I'll catch you in the next explainer.